Super Ret Smoothie Factorial ANOVA Part 10. Okay, two-way ANOVA, raw data. Here's our two-way ANOVA table that we're working from. And we have already calculated the sum of squares and the degrees of freedom. Now it's time to move into the mean squares of each of the sources of variance, okay? This is the very most basic part there is. To find a mean square, you simply take the sum of squares from that row and divide it by the degrees of freedom from that row. I'll say that again. It's the sum of squares divided by degrees of freedom that gives you your mean squares. We write it like this. So the mean squares of factor A, we always write it as a subscript down there, mean squares factor A, equals, it's just going to be 200 divided by 2. Comes out to be 100. Easy. And you just repeat that for each and every row, every source of variance, right? So the next one is going to be the mean squares sub B, and that's just going to be 2 divided by 1, and that's 2. The interaction mean squares is going to be 884 divided by 2. And within group, mean squares is simply going to be 50 divided by 30. And I'm going to round that to 1.7. And in the total, we don't use, okay? We never figure out the total mean squares. It really doesn't make any sense. We just skip it there. So we no longer fill out anything on the total column here. But now we know the mean squares. We know not to use the total mean square. This is very, very important. The within groups mean square is also called the error term. It is very, very important that you know what this means. This is your error term within group mean squares. And what you're going to do with that, it's going to be the denominator for all of your F ratios once we start making our comparisons here with the F ratios. So your within group mean squares is your error term and will be the denominator for all of these F ratios. So that's it for this one. MGZ out.